Welcome back. Track 1, SFT Fundamentals, is 21 lessons covering the concepts behind supervised fine-tuning. No code yet, that is Track 2, but every mechanic you need to drive a fine-tune deliberately is in here. Part A covers the data side. What SFT is, how the loss mask works, chat templates, tokenization, gold sets, and the structure of the training loop. SFT, Supervised Fine-Tuning, is teaching a model to imitate target outputs on a set of input-output pairs. The optimizer nudges the model's existing weights so that, on your data, it produces the completions you specified. What actually changes is the parameters from pre-training, small, deliberate edits. SFT is good at narrow behavior and format adherence. It is not good at injecting knowledge the base model never had. For that, reach for retrieval. SFT is one of 4 objectives. SFT itself, imitate the target completion. Preference optimization, DPO or ORPO, learns from pairs of preferred and rejected outputs. RLHF, the heavyweight ancestor, a reward model plus reinforcement learning. Continued pre-training, build base ability on raw text. SFT covers most narrow task work, preference tuning when better is judgment, not a single right answer. One SFT example is a prompt and a completion. Conceptually simple. The catch is the loss mask. During training, the loss is computed only on the completion tokens. The prompt tokens are masked out, set to -100 so cross-entropy ignores them. The model learns to produce the answer, not to echo the question. And do not forget the stop token. Without it, generation runs past the answer and rambles. Instruct models speak in turns, user, then assistant, with explicit role markers wrapping each message. The chat template is the tokenizer rule that renders a list of messages into the exact formatted string the model expects. You do not write the role markers by hand. You call apply chat template and the tokenizer inserts them. At training time, the loss mask covers only the assistant tokens. At inference, the generation prompt is the trailing assistant marker that tells the model it is its turn. What does an SFT example look like? It depends on the task shape. Classification, prompt plus a single label. Extraction, prompt plus a structured object, spans or fields. Generation, prompt plus a free-form completion. Multi-turn chat, prompts and replies across several turns. The shape determines what goes in the completion, and the completion determines what the loss covers. Tokenization in practice. Batching needs rectangular tensors, so shorter sequences get padding tokens. The attention mask is the per token 1 or 0 that tells the model which positions are real. If an example is longer than max sec length, it is truncated. To avoid wasting compute on padding, you can concatenate short examples into one long sequence. And padding side matters. Most decoder-only models want left padding at inference. Data quality. 3 things make or break a fine-tune. Deduplication. Remove repeated rows and near duplicates. Class balance. Do not let the majority class hide a model that ignores the others. And the split train validation test. Keep them disjoint and never train on test. Representativeness matters too. Your training data should look like production inputs, including the hard cases. The decision boundary lives where you put data on both sides of it. The gold set is your North Star. A small, hand-checked set of correctly labeled examples that the model never trains on. It is where you measure quality. Every change is judged against the gold set. Build a trustworthy one. Real production-shaped inputs, label them carefully, and never touch them with training. The gold set is not the test split. The split rotates as your data grows, the gold set stays. It is a quality contract. Put it all together, the training loop. One step is forward pass, compute the loss, backward pass for gradients, optimizer step to update the weights. The optimizer is atom W, atom plus weight decay, the workhorse for SFT. Every batch is one step, many steps make an epoch. Checkpoints save the model, so you can resume or roll back. Validation, passes run on the held-out set, so you can watch the eval loss without leaking test data. The whole loop is just predict, measure, nudge, repeated. That is part A, the data side. You now know what SFT is, how the loss mask shapes what the model learns, how chat templates and tokenization work, what makes a gold set, and the structure of one training step. Part B picks up the training dynamics. Cross-entropy, learning rate, batches, low-raw, GPU memory, reading loss curves, plus decoding controls and dataset formats. See you there.